Good evening, everyone. Welcome to today's class. Uh, we'll look at the model context protocol. Please confirm that you can all hear me clearly by putting a thumbs up. Okay, thank you. As usual, we'll start with a recap of what we talked about in our last class. That would be our class on Tuesday. So who would volunteer and give us the recap? Any volunteer? Victor, Tosin, David. No one wants to volunteer. All right, David, please go ahead.
Okay, good evening, everyone. Though I cannot really list out everything that we did last week, and that's because my network was kind of,
Yeah.
again. But then again, the ones that I picked, from Tuesday class was about the anatomy of tools, and tool creation in LangChain, which is basically using the tool decorator from LangChain to create tools. Um, I also grabbed um, the one which is the least privileged access, which is basically um, limiting the access of the agentic AI to some, when these agents want to basically interact with a database, there are some limitations. There are some private, information that this agent should not be able to access. So therefore, you limit it, right? So I also grab the part where you talk about the PII detection and masking in tool engineering, whereby, we kind of did something about PII scrambling and data masking. Yeah. So that's all from me.
Okay. Does anyone have something to add to what David has said?
Yeah, so let me add one or two things to that. So we also look at the approaches in creating tools as well too. So that's where we look at using the Art2 decorator now, which is recommended, and then which is basically developing a Python functions regarding that. And then we also look at instantiating or yeah, I mean, if I'm correct, instantiating the tools as well too. That's one approach. Yeah. And then talks about subclassing these tools as well. Like remember very well too. Then we talk about vulnerability of tools. You know, when you equip your agent with tools, it makes it more vulnerable. So you explain extensively in that regard as well too. So how the capabilities of agents exposes to more vulnerabilities and look at the risk vectors too as well. Yeah, we talk where you mentioned direct injection, and elevated privilege escalations. So, so that's what I can remember now what we discussed last week. And we
Okay,
talked
thank
about the library as well, having a library of tools, which is fall under the skill vector.
you. Thank you very much. Um, so I guess we just move straight to what we have for today. Today we'll be talking about which was actually developed to solve um, every agent framework. Of course, there were data sources before agents. Now, for you to connect a data source to an agent framework, you had to build a custom connector. The implication was that for every agent framework, you needed a custom connector uh, agents that you're building with that framework to have access to. And so this created an N by M challenge where you needed for each framework, you needed connectors for each data source. And so MCP essentially was an attempt to address text protocol. Essentially, it is a protocol, it's a standard for connecting tools to agents and to LLM, providing context to LLMs. So it allows LLMs to connect to way and also for them for context to be provided to LLMs in a standardized way. MCP provides a universal interface, universal in the sense that any LLM, any agent can connect to it. So it provides for connecting AI applications to external data sources and tools. So universal in the sense that, like I mentioned, any AI application can connect to it once it adheres to that the standard. If okay, you can access the MCP standard specification by going to this URL. I'm going to post the URL in the Discord channel at the end of this class. Now, the main benefits, the key benefits of MCP include reduction in code duplication. So instead of building connectors for each, if you have a tool, you need to build connectors for each framework that you'd like to have access to that tool. So instead of duplicating code by doing that, if you just use MCP, you just build your tool once, and that serves every framework that wants to connect to it, as long as that framework implements the MCP standard. Another benefit is provides improvement in the standard. It specifies that every MCP server will find out what an MCP server is. That every MCP server must expose the tools that it provides. You must expose those tools. So tools you have, and it gives it all the tools it has with their descriptions. And so with MCP, tools are more easily discoverable. Without MCP, you need to explicitly know that that tool exists. Of course, you even need to directly integrate the tool to your AI application. Improve the speed of agent deployment. in that you already have the tool available. Just need to build your agent and it queries the MCP server that has that specific tool, compared to when you have to build the tool yourself and integrate it into an agent. So the MCP deployment. Any questions so far? All right, so we continue. Now we'll look at the architecture of MCP. Essentially, MCP if it uses a client server architecture where there's an MCP client and an MCP server. The MCP server is a standalone program or a process that provides, or rather exposes tools, prompts, and data to clients. And of course, it provides context to clients because the results of the tool, of calling that tool, the data that it exposes and all that are context that it provides to and the MCP client itself is a component of an MCP host. The client is what connects to the server. It enables that connection between the host and the server. And so when the host wants to request context, it does that through the client. The client will request the context from the server provides the context to the client, and the host now has access to that client. The host itself, MCP host, is just like an AI application or a framework or an environment that coordinates or manages one on the MCP clients. It could be the agent you are building. It could be something like cloud code. It could be whatever AI application. The important thing is that an MCP hosts an AI application that coordinates or manages one or more MCP clients. Now, how do MCP clients connect to and exchange data with two basic platform mechanisms in MCP? The first is the standard IO, which is used when the client and the server are running on the same machine. So it's for local communication and it's high speed. Then, it's the best use case is in CLI tools. Then you also have the streamable HTTP mechanism or server sent events SSE. I'll explain difference here. But whichever one of these two is used for remote communication between an MCP client and an MCP server, they're not on the same machine. It's over a network, and they are best for cloud hosted tools. And once it's remote, once it's across the network, they are not on the same machine. Well, even you can still use it on the same machine by using local host. But then if they are on the same machine, you might as well just use the standard IO mechanism. Now, streamable HTTP is the current, if I may say, state of the art transport mechanism for MCP. MCP was using an SSE for remote communication. Yeah, SSE is still supported, but just for legacy purposes. But I mean, if you're building now, best use streamable HTTP, but less request. But if it's a client, then you should use streamable HTTP, except if the server you're trying to connect to does not support streamable HTTP and only supports SSE. Any question? Okay, so we continue. The P servers. Essentially, there are three major features that which are tools, resources, and prompts. So an MCP server can either access tools from, an MCP client can either access tools from an MCP server, or it can access resources or prompts. We're going to look at what each of these features actually comprise. Okay, David or anyone else, am I still breaking?
Yeah, like you, some of the times it just keeps,
So, order. I can switch, but I really wonder why this keeps happening. This is really recent. Just a moment, please. Okay, can you hear me?
Yes, we can hear you clearly, sir.
Okay, so it's not breaking anymore.
Yes, it's not.
Um, is there any part of what I talked about prior to my switching to a new network that you would like me to repeat? Maybe any part that you lost? Is there, or do we just continue?
Part before this MCP servers.
I didn't hear you, Tosin.
I said before the MCP server tools. Slide before this slide.
This?
No, not this one. Yeah. I think you were breaking
Okay,
something. Yes.
okay, okay. So I said that MCP uses a client-server architecture. Um, And I explained that an MCP host is an AI application or a framework that, or even an environment that coordinates or manages one or more MCP clients. It could be your application like ChatGPT. It could be a tool like Cloud Code. The important thing is that it manages at least one MCP client. And then the MCP client is the component of the MCP host that connects to the server. The job of the MCP client is to connect with the server and to obtain context from the server on the host's behalf. And then the MCP server is a program, a standalone program or a process that exposes either tools or data or prompts. And then if it's either tool or data, prompt or data, that provides that as context to the MCP client. Or for a tool, it provides the output of that tool's invocation as context to an MCP client. And then I talked about how MCP clients and servers exchange information, exchange data, how they communicate. I mentioned that there are two transfer mechanisms, namely the standard IO and streamable HTTP. The standard IO is used when the client and the server are on the same machine. So it's used for local communication and it provides high-speed communication. It's best for CLI tools, local CLI tools actually. While the streamable HTTP is used for remote communication when the server and the client are not on the same machine, and so they need to communicate over a network. And it's best for cloud-hosted tools. I think I also mentioned that, well, you can still use streamable HTTP when the client and server are on the same machine, if you use the local host as the server's IP address. But then, I mean, if they are on the same machine, why use that? Except you're trying to show that just want to keep them entirely separate. If you're running the client server, for example, on a Docker container, you know that essentially logically that Docker container is a separate machine, so you need to use treat it as if you are accessing the server remotely. And then I mentioned that server sent events was originally what MCP used for remote communication, but that the current standard is streamable HTTP, but it still supports server sent events for backward compatibility. So if you're building an MCP server, it's best to use streamable HTTP transport. But if you're building an MCP client, then you should use what the server you want to connect to supports. So if the server supports streamable HTTP, you use that. But if it doesn't, if it only supports server sent events, then you just have to use that. But I've had eventually, most likely MCP will stop supporting server sent events. And is there any question? Okay, so right. Then I talked about the core features of MCP servers, and I mentioned that they provide tools and prompts and resources, and we're about to start talking about MCP server tools. So an MCP server tool is just like the lang chain tool that we looked at on Tuesday. The only difference is that essentially MCP server tools are defined as JSON schemas. So they are interfaces that LLMs can invoke. And the schema clearly defines the inputs, outputs, and the tool performs a single action. We talked about when we talked about whispered access, we said the tool should have essentially a single action, a single thing it does, a single responsibility. To execute an MCP tool for an MCP client or an MCP host to execute a tool on a server, it may be required for the user's consent to be obtained. Right? The standard provides that based on exactly how the application is built, may be that before you can execute this tool, before an MCP host can request to execute a tool from an MCP server, of course, to the client. They have users' consent, they have to be obtained. So that if this user says no, don't execute this tool, then the post should never request execute that tool. And the operations that the MCP server, the MCP protocol supports on MCP servers include listing the available tools on the server. So tools list operation is used to discover the tools that are available on servers, and it returns an array of the schema for the tools. Of course, the schema includes the official schema of the tools. There's also the execution of a given tool, which is the tool's call operation, and this operation returns the result when that tool is executed. Any question? All right, well, here's a sample definition of an MCP tool. The schema here includes the name of the tool, its description, and its input. Its inputs. So you can see the input schema is an JSON object that defines the arguments, the parameters for that tool, and specifying the type for each parameter and its description. And of course, it also the tool definition also specifies the required input parameters as a list. Now, MCP server resources. While MCP tools can take action, so they enable a client to request the server to take an action. MCP server resources provide context, like it could be from static files, or it could be from APIs or from databases, essentially just to retrieve data and provide that data as context to an MCP host through the MCP client. There are two categories of MCP server resources. It can either be a static resource, in which case the URL is fixed. So I should have mentioned that each MCP server resource has a unique URI and also declares its MIME type. That way, the client, or rather the host that requests that resource, will know the most appropriate way to handle the resource with context returned by that resource. And so the resource can be either a static resource, in which case it has a fixed URI, or it's a resource template, in which case it has a dynamic URI. Any question? All right, continue. Now, the protocol of operations on MCP resources include the resources list operation, which is used to discover available direct resources, and it returns an array of resource descriptors. There are the resources / templates / list protocol operation rather, which is used to discover the available resource templates. The difference between these and the resources list, resources templates is our resources list. Difference is that resources list is used to discover static resources, while resources templates list is used to discover available resource templates. And so resources templates list returns an array of the resource template definitions that are available on that in the given MCP server. There's also the resources read operation, which retrieves the contents of a specific resource. And so what it returns will be the data, that resource data, as well as metadata, its metadata. And then there's the resources subscribe operation, which allows clients to subscribe to monitor a given resource in case it changes. So when you subscribe to the resource, if there's any change on that resource, then the server will send a notification to the client that has subscribed to that resource. And so the what resources subscribe, what it returns is confirmation of that subscription that the client has successfully subscribed to that given resource. And now here's sample of direct resource type descriptors and resource descriptors. Have a URI with the name of the resource, its description, and a bind type. And then here's sample descriptors for resource templates. Here you have the URI templates, which is dynamic, it takes parameters. You have the name of the resource template, you have its title, you have its description and the bind type. You could also have optionally, you could have annotations like priority and so on, and audience and so on. Any questions so far? Okay, let's see. Look at the MCP server prompts. It's just the normal prompt templates that we've been using for prompting LLMs. But in this case, the important thing is that MCP server provides this prompt as a guide on how best to request certain services from AI models. So they are like structure templates. They're essentially prompt templates, right? Yeah, they can be context aware in that they can reference the available resources and tools, thereby enabling the creation of very comprehensive workflows on the server. They are user controlled, so the user must explicitly invoke that prompt. If you request the prompt, you're just going to get the prompt. It's not going to run that prompt. For you to run that prompt, you must invoke it on a model explicitly. Now, the protocol operations on MCP server prompts include this prompt discovery, where you run the prompts list operation, and it returns an array of the prompt descriptors of the prompts that are available on that server, and then the prompts get will retrieve the details of a specific prompt. So it just returns the full prompt definition with arguments. And here's a sample descriptor from an MCP server prompt. You have the name of the prompt, you have its title, you have script description of the prompt, and then you have the arguments that prompt takes. For each argument, it specifies the type, and in case of that, all that metadata is required. Does it have default values? Does it have a range, and so on? Any question? Okay. Now look at MCP clients. The MCP clients also have core features which include elicitation, routes, and sampling. We're going to look at these in a bit more detail. Now, when in an MCP, in a workflow involving MCP server client communication, it is not compulsory for all the information to be provided to the server ab initio. So if the client has requested tries to say call an MCP server to or tries to access a resource or something, if the server discovers that there is some additional information that it needs from the client which wasn't provided in the original request, the server can contact the client to request that information from the user, obviously. And that is what elicitation is used for. Elicitation is used for the server to request additional information from the user in order for it to be able to process the request that it got from the client. Of course, that request is on behalf of the user. So it facilitates more dynamic workflows. The client, of course, the user wants something to be done towards that doing the host. That means that there's need to make use of an external resource that's available on the MCP server. External resource in this case can be a tool or a resource or a prompt. And so the host initiates a call to the server via the client, and then the client receives this request, and it sees that, hey, there is some additional information that it needs to fulfill this request, which wasn't provided. It initiates an elicitation request back to the client to say, hey, I need this additional information. The client surfaces this request to the user, and when the user provides that information, the client forwards it back to the server, and the server is then able to continue processing the request. Now, the user interaction mode, I think I've essentially described that. So the client will display elicitation requests when it receives those from the server, and that in displaying it provides clear context about which server is making that elicitation request, why the server is asking for that information, and how the server will use it. Excuse me. So it also includes a schema for that request, a schema that it will use to validate whatever response will be sent back to the server. And so when this elicitation request is received by the client and surfaced to the user can decide to provide the requested information, or the user may decide to decline that request option. They can either provide an explanation for declining or not, or the user can decide to cancel the entire operation. Hey, if the user is not comfortable with that elicitation request, the user can decide to cancel the entire operation that led to that elicitation request. Now, when the user provides the information, the client validates the information provided by the user against the schema, and if the validation is successful, returns that information to the server. Now, elicitation should never request password or API keys. Essentially, secrets should not be requested via elicitation. And if there are suspicious requests, the client should provide warning about that and should let the users review whatever data that will be sent to the client before it goes ahead to send the data. Any question? All right, continue. So here's a sample elicitation request. Yeah, I must mention here that MCP uses JSON RPC requests sends them over HTTP. Okay, so the decision request contains the method and then parameters, which include the message. Here, this message is what will be presented to the user, which is, hey, the server is saying provide your GitHub username before you can proceed with generating the request the report that you requested. And then the schema. The schema here is username, which is the user's GitHub username, and that's the only thing the server is asking for. And of course, it is required um, fields that's given. Now look at the MCP client routes. So routes essentially they are used to communicate file system access boundaries. Essentially saying, hey, server, when you're processing, restrict yourself to files within these boundaries, files and directories within these boundaries. So what they essentially consist of file URIs, and they help servers to understand the scope of available files and folders that can be used in addressing the or can be accessed and addressing the user's request. And they are valuable for scoping the context to prevent accidents, like where the server now mistakenly goes to delete or modify or an unintended content. But it's important to know that MCP client rules do not enforce security restrictions. They are just suggestions. Hey, server, they are like requests. Hey, please restrict yourself. Like somebody comes to your house, you say, hey, I'm going out, so you're in the house. Please do not go out. Restrict yourself to the living room. Don't go to the kitchen. Don't go to the bedrooms. Now, as you've left, if you do not put physical restrictions, like maybe you place a dog at the door of the living room, so that if this person wants to pass here, stop him. It's left for the person to decide whether they have the integrity, they are well behaved enough to respect your request. That's just what rules are. So if the server is well behaved to stay within those bounds prescribed by the rules, but if the server is not well behaved, it will just try to go anywhere it wants. And so it's important for the client or whatever to also implement access controls. You don't rely on routes or access control. You have to implement access control. The routes are just like a request, say, please respect yourself and keep to these boundaries. But then if the server is malicious, it will not hit to that request. And so the user interaction model for routes, if you specify rules, when the user opens a folder, the client automatically expose them as well. That's automatic root exposure. And the server can request the roots at any point. So once the user opens the folder, the client exposes it as roots. When the server requests roots, that folder that was opened becomes part of what the client responds to that. So the server will know, hey, this client is working with the contents of this folder, and so it's available as part of my context, or the scope of what I'm currently working on. It's also possible to specify the routes manually through configuration. So it's not just that the user is opening a file, you can specify the routes manually. Well, this is for advanced users anyway. And here's a sample. There are samples of root notification, which will be to specify the URI for each root as well as its name. Any question? Now sampling. You could have your MCP server. You could provide or you could integrate your MCP server with AI models so that if addressing the user request requires invoking an AI model, the server can do that directly. But of course, let's assume that your host is an AI agent. It has it has integration with AI models. And now the MCP server also have AI models integrated with it. That's you have it, you are integrating two models, so you have two different integrations of AI models on the server side and on the client side. Of course, if you're using paid APIs, each of these involves some costs. And then you too, if you are building an MCP server, are you willing to bear the cost for LLM requests, for example, where invoking an LLM is required to address a request that you receive from clients? So MCP sampling helps, it's a workaround, helps to solve this challenge in that if the MCP server requires access to an AI model in order to address the client's request, it can send a sampling request to the client, since typically the client is an AI application, and so it has access to an AI model. So the server can say, hey, can tell the client, hey, I need access to an AI model in order to address your request. But I don't have access to any AI model. But you do. So please take this request, invoke your AI model with these prompts, and send me the results because I need those results to address your request. So in so doing, the client maintains control of user permissions and security measures. The server does not have to be integrated with AI models, and then the user can review and modify both the original request and the generated response before it returns that to the server. And the user interaction model goes follows. A sampling request may require explicit user consent, in which case you don't just allow it, if you so desire, don't just allow servers to go making sampling requests and maybe they might be running up API costs for you. That this mechanism enables the user to say, hey, I want server to be able to make sampling requests, or no, I don't want server to be able to make sampling requests, and so the client can show what the server wants to analyze and why. Of course, showing to the user can show the user what the server wants to analyze and why the server wants to analyze what. So, what's the justification for the server requesting this interaction with an AI model? And it's up to the user to either approve or deny that request, or perhaps even modify it so that it fits within what they are comfortable with. And the clients can display the exact prompt, model selection, and so on, not different levels of information about the sampling request. And the user, this allows the user to review the response, and of course, either stop the whole process or not before that response is forwarded to the server. The user can set preferences. Essentially, the user is in control, or rather, the model provides mechanism for the user to be total control. So the user can either configure auto approval for trusted operation, or they may require approval for everything. The client can also provide options to redact sensitive information as a way of avoiding PII leakage and exposure, or whatever. It may not even be PII, any sensitive information. Now, the model specifies that both clients and servers must take appropriate action to handle sensitive data to the sample. For example, scrubbing PII. And then clients should implement rate limiting and validate all message content. Implement rate limiting to reduce the potential for the server to rack up a hefty API bill for them, or even reduce the propensity for injection through sampling requests. And then essentially sampling provides like a human in the loop design, since it enables the user to approve and validate everything. So this helps improve security such that sensitive data doesn't get exposed without the explicit consent of the user. And here is a sample sampling request. Specifies the method, and then the contents include the message. What is the message that the server is requesting the client to pass, prompt an LLM with on his behalf? So that message is a list of objects, and each object specifies the role as well as the content. The content here is the specific prompt. And then but this is for the user prompt anyway. It can also specify a system prompt, can specify maximum tokens, temperature, and so on, in a number of other metadata. Any questions so far? So at this point, we are going to look at a demo MCP server. I will stop sharing my screen for a short while so I can share my IDE. Please let me know when you can see my screen. Can you see my screen yet? Okay, thank you. Here, this server was built with fast MCP, the fast MCP library or framework, if you care. You could also use the MCP Python SDK for this, but fast MCP is a framework that helps to what was it provides a higher level, allows you to a term escapes me. The MCP SDK is lower level, right? The fast MCP framework, what's that term? It enables you to, it's more higher level. It handles a number of the lower level processes for you. Okay. If you know how to you use backend frameworks like Fast API, and the Flask. It's somehow similar to that. And you can actually even integrate your fast MCP server with, say, a fast API backend application, so that fast API backend also serves the MCP server, provides endpoints for the MCP server. And then your fast MCP server also would run typically with a UVCon, except you specify another server to run it, but by default you use. Excuse me. So here I defined a custom health check endpoint, so that you can use this to know whether your server is actually running remotely, and then for some custom deployment environments actually need this health check routes to for monitoring reliability and taking action in case the server goes down. Maybe responding a new process to run the server. This is essentially this server. There are tools that we have used before. This server just provides those same tools as MCP server tools. The tools that I think was an example where we had tools to get the temperature in a given African campus city, as well as to get the local time in those cities. So that's essentially what these are. This is essentially the same logic that we implemented earlier on, just that now we are having them as MCP endpoints. But here too, we also include resources. We have a resource here for listing the supported cities. If you remember, we specified cities that are supported by those tools, right? I think how many of them, I don't remember, but 1, 2, 3, 4, 5, 6, 7, 8. I think there are about 9 or so, 9 cities. And so this resource lists all the supported cities. So when you invoke this MCP resource city list, it will give you a list of all the cities that are supported by this server. Then we also have this is a static resource. Then we have a resource template here that can give you the description for each city, right? So when you invoke this resource, you get a description of the city. But if the city doesn't have any description, or if it's an unsupported city, if the city is not one of the cities that are supported, one of those 9 cities, is going to return an error, a value error. Well, the validate location method is a helper defined up here. Yeah. So when the city is not one of the supported cities, it raises the value error. It says invalid location and says must be one of the valid locations. And so when you invoke this resource and the city is not one of the supported cities, is going to return that the the content of that value error. Then if the city is supported, but there is no description provided for it, then it will tell you no detailed record found, although it's a supported city. There's actually a dictionary of city descriptions here. It's like just like a mock rag data that provides descriptions for 4 cities: Nairobi, Cairo, Praia, and Abuja. So if, for example, you invoke that resource for Gaborone, which doesn't have any description provided for it, you get what you're going to response you get will be no detailed record found for Gaborone, though it's a supported capital city. And then we have prompts, just a sample prompt. This is like for this, they are supposed to be say like a tool for creating travel brief. So this prompt gives you the prompts that you can use to invoke that creating travel. If you want to create a travel brief, this is the prompt. So if you invoke this prompt from the client, this is what you'll get. Please provide a comprehensive travel brief for city name. Use your tools to get the current time and temperature, access the city description, and so on. So if you want your agents to get create a travel brief for you, this is the prompt that you can use. And so the agents would now know that this is telling the agent that they can get the description using this resource and so on, and that there are tools for this and that. So, it didn't actually specify the endpoints for requesting the tools, but this was just a sample. But ideally, you should also specify that so that this is a prompt you can give to your agent, which is the MCP host, for it to use the resources available on this server to create a travel brief for you. That's essentially what this prompt is doing. And then the tools, these are the same tools that we had in the previous example. I think that was in our 2 or so, if I remember right. The get location temperature, get offset from UTC, get local date time by offset. Okay, we had get local date time. That was what we had initially, but here I've expanded it to have get local date time by offset, which is the original get local date time function we had, tool we had, which takes the offset from UTC. But here I've also provided a tool for getting the local date time by city, in which case, in the previous workflow we had, for you to get the local date time, you first need to call get offset from UTC. And when you get that offset, you now call get local date time using that offset. But this tool now just enables you to provide the city name directly, and the server will get the offset itself and then get the local date time and then provide you with that local date time that given city. Excuse me. And then here is a tool for retrieving secure stats for the city. It's still like a demo. This I included this tool to enable demonstrate excuse me routes and so on. And so if the how do I explain this? If there's a request for routes, right, like here, the server is requesting routes. This is supposed to trigger the routes on the client. That's essentially what this is. So the server requests for routes, and then it outputs what the routes that the client responded with. And this here is to enable the server to echo like to the server logs its own actions, but this enables it to forward those logs to the client so that the client can capture the logs from the server. I think that's the right term. This here enables the client to capture the log from the server so that the client can get this, and it will be able to capture that the server requested routes from the client with a given request ID, and that these were the routes that it received. You may not have access to the server to actually get its logs, but by being able to capture, by implementing the log capture on the client, then you'll be able to capture necessary logs to allow you to, what's the term, debug from the client side. As when you're getting issues, you can get an idea of what exactly is happening on the server from the client. So this helps you to debug. I'm using info here as a log level. And then where there is tools list, if the tools change, you can send a tool list change notification to the client. This also, the essential thing about this is to make the interaction between the client and the server more dynamic. I'm just putting this here for demonstration, right? So if there is any change in the server, for example, there's a tool that is no longer available, or a new tool has become available, the server can send a tools list change notification to the client, and the client will get that and know, hey, okay, there's a new tool that I can use, and so on. And here is trying to demonstrate elicitation requests. Here I've specified the schema. If you remember, when we looked at sample elicitation requests, there's a schema that this client will use to validate what it will send back to the server. And so here, the server makes the elicitation request, and essentially this is like saying, hey, I need an access code to enable you have access to certain functionality on the server. Obviously, when the client made the request for this tool, probably they didn't provide. It is supposed to simulate a situation where the client did not provide that server access code when it called, it requested this tool. And so the server makes this elicitation request saying, hey, client, please enter your server access code. And when that is received, it checks if it's received or if the action in the response that it got is accept. That's, if you remember, we mentioned that the client can either accept the request, and in which case it provides the information, or it can decline the request and optionally provide explanation, or it cancels the entire operation. And so this checks, did the client accept and forward the information? Or if it did, then it just, in this case, you take the requisite action. In this case, or in this actually check, if the client did not accept, actually that's what it's checking. That means if the client did not accept, this is just a notification to the client to enabling the client to capture the server log to say, hey, there has been an error you canceled the entire operation, or you provide an invalid input. Of course, you can make this more where you check specifically whether it's a cancellation or invalid input provided, and then it returns this. But where the client actually provided a passcode, and then it checks if the passcode is, well, essentially this is a very, very naive authentication logic. But typically you implement a more robust one in your client, assuming you have a workflow like this. And so if it's not the correct code, it logs an error, it forwards that log to the client for the client to capture the error, and it returns this. And otherwise, that means the client provided the correct access code. It also logs its server, forwards this to the client, so the client can also have a log of what's happening on the server. And finally, it reports progress. This is also demonstrating a feature of MCP servers, which is reporting progress. And what this does is just to trigger the progress handler on the client so that he can notify you of the progress in handling a given request. So if the request on that the server is trying to address is a complex one that takes time, good UX would entail that you provide progress notification to the client, which the client can display as a way of perhaps keeping the user engaged while their request is being addressed. And then once the processing of that request is done, the server returns the final result. Here we're just returning stats for Sanso's city radio. Of course, like I mentioned, this is like a dummy tool just meant to demonstrate some of the features for both the client and the server. And then you can run it here. This run essentially would run this with the defaults, which include standard IO transport. If you want to execute with a different, then you can specify streamable HTTP transport. You can specify the host IP as well as the port. I provided those myself at the point of invoking the client, because I use the fast MCP CLI, and with the fast MCP CLI, you can provide, you can specify the transport mechanism as well as the host and the ports at the point of invoking the server. I already have the server running in a separate terminal because I'll run the client from my IDE. Okay, so we'll go back to the slides. I'll stop sharing a bit and to enable me open the slides. But I think the next thing will just be, I think it's just a demonstration of, yeah, we can just continue in the IDE, because what we have next is just still demonstration of MCP client. So we'll just continue on the IDE. Okay, I can try to, let me share first. Please let me know when you can see my screen. Okay, so we'll go to the MCP client. Now, I have two variants of the MCP clients. I implemented a client still using the fast MCP framework, as well as the same clients, well, or more or less same clients using LangChain's MCP integration, or rather LangChain's MCP adapters. So for the clients implemented using fast MCP, well, the key thing here is it uses callback handlers to handle most of the features. Like elicitation, you just implement a handler for elicitation. You must not call it a elicitation handler anyway, but because you have to pass it to the client at the point of instantiating the client. Okay. So this is the elicitation handler that was defined. And essentially what it does is when an elicitation request is received, it just prints this out. Elicitation request received from the server with the request ID, and then it prints out the server request. This essentially it works through the schema that was provided by the server, and it provides it asks the user to provide values for each parameter in that schema. So it performs recursive what's the term? It recursively walks through the schema, and at each point it asks the user to provide the given information, requested information. And so the user can decide, like we mentioned, either to accept or not. And if the user, whatever the user's decision is, it provides that response to the server, either action accept with the content the user provided, or a decline if the user cancels that request or declines. And then there's a log handler, which handles you remember I mentioned that the client can capture logs from the server. And so this is the handler for that. So when the server forwards logs to the client, this handler takes care of that. Essentially, it just logs what was forwarded from the server. But in this case, I prefixed that with captured so that it can be distinguished from the logs that the client itself, its own logs. And of course, yeah, automatically it tries to get the log level as specified by the server itself. So if the server use context.info, this will log it as an info log. If the server specified a debug, say use context.debug, for example, this will log it at that level. And then there's notification message handler. If you remember, we talked about a tools list change notification on the server. So this handles, this callback handles such notification. Like here, if it's a notification tool list changed, this just prints what it is. If the method is a resources list change, it just prints that resources have changed. If the prompts list change, it just prints that it could be any type of notification that you receive. You have to implement your own logic to handle the different types of notification that could be received from the server. And then this one is the progress handler. I think that's one of the last things I mentioned, that when the server, the current process that the server is running, or rather the current logic, its current processing is taking time. Good UX would entail notifying the user about progress. So this handles that. So when it has such progress updates from the server, this here will update it. But essentially what this essentially just prints out a progress message, the progress, and provides percentage and so on. In your own implementation for a real live AI application, possibly display a progress bar or whatever. And then the root callback. If the server sends a root request, this handles it. Essentially, it just updates the roots of the client, and by updating that, the server can it also return that root. So, but typically, once you update once you update the roots, the server would receive that, right? The idea here is that this can dynamically update the roots. So you can implement dynamic logic to dynamically update the roots, assuming the roots were not statically defined at the point of initializing the client. And then this is the sampling handler, which is supposed to handle sampling requests from the server. And so when you receive sampling requests, here is where you implement the call to the LLM using the prompts as contained in the sampling requests, and then where you also implement surfacing both the prompts, surfacing the prompts that sampling request the user to approve, assuming that's the logic, the business logic. And then when the LLM provides a response, you also provide surface that user for them to go through and decide whether or not they want to provide that to the MCP server. And where the user approves all that, they return the response to the MCP server. And here we instantiate the client. Now you can have the client. Okay, I mentioned that when you are instantiating the clients, you pass those. Okay, this is just a config. This is just a config for instantiating the clients, just to improve maintainability, so that we can just change yourself without having to go changing the code down there. But the key thing is that you need to pass, when you're instantiating the client, you need to pass the different handlers to it, those handlers you implemented. And that's why I said you do not have to, like the illustration handler, it's not compulsory to name it illustration handler. Whatever you name it, you define that function as, that's what you pass here. Well, we pass to the client when initializing it. And then typically when you initialize a client, when you instantiate a client rather, not initialize, it gets automatically initialized, but you can specify that the client should not be initialized immediately, assuming there are other operations you want to undertake before you initialize the client. And you do that by passing the auto initialize parameter and setting it to false. By default, it's true. Yeah, this is just supposed to allow to make this client, or rather, it's supposed to handle for flexibility to handle the different transport mechanisms, whether it is the streamable HTTP or the standard IO. For standard, if the server transport mechanism was standard IO, you need to pass the path to the server script. But if it's HTTP transport, then you need to pass the URL for the server, the base URL of the server. Yeah, and so this is where we instantiate the client. We use those config the config dicts that we defined here to instantiate the server. So you could have ordinarily you could have just passed this directly without using a config dict, but I decided to use this to make the code more flexible so that I can remove either of these at any point without having to change the code down here. And then this is essentially where I execute the client, and you use a context, an execution context for that. Now, here is where you will perform whatever action you wanted to before initializing the clients. Now, initializing is essentially asking the server to connect, the client to connect to the server and negotiate what's the term? Negotiate, okay, let me use the terms of their communication, right? If you don't want to do that, then you should you should not specify auto-initialize as false. If you auto-initialize, it's true by default. So if you don't add this when you instantiate the client, then it gets initialized automatically. And here is where I initialize it, the client manually, since I set auto-initialize false. And at each point, I try to capture logs so I will see what's happening. Here, the client is making a list prompt request from the server. So it's supposed to get a response from the server, giving it a list of descriptors for the prompts that are available. And this tries to print that. Now, I have this here to capture all the prompts, resources, and tools on the server at once the server is initialized. You don't have to do that. But we'll explain when we get further down, you'll see why I implemented this logic. And then this also captures all the resources available on the clients by running the list clients method. This does the same thing for all the tools. And now here's where the different operations are done. This calls a specific tool. So here you need to pass the name of the tool. Well, actually the key that is used to capture that tool in this tools dictionary, which really I think is actually the name of the tool. Let's look. Yeah, tool dot name. So when you pass the name of the tool to this function, it will initiate a tool call to operation on the server. And so that tool is invoked and it returns whatever response the tool gets. But really, this tries to validate whether that tool is even available on the server. And that's why I did that initial list tool, so that you don't go trying to call a tool that's not available on the server, because automatically you're going to get an error. So this is saying if the tool is not available on the server, don't bother making that a round trip on the network just to get an error, right? But then, I mean, if the tool was not available and it's called, the server should return an error message saying, hey, this tool is not available. Then here is for retrieving a specific, the prompt retrieval to retrieve a specific prompt. It follows a similar logic. It checks, is that prompt available on the server? If not, it returns this. And if it is available, it returns whatever response it gets from the client. And this one reads a given resource from the server. It also tries to validate whether that resource actually is available on the server, it's exposed by the server. And then if it also tries to validate the URI. Does the URI you provided match the URI it captured when it got the list of resources from the server? If not, C returns an error message. Essentially, all this is trying to avoid requesting an unavailable resource from the server. So you don't go making um, um, network or initializing network traffic that is guaranteed not to provide anything valid. And this is where it actually um, makes that request for the resource and outputs whatever it got from the server. And this is where it's actually executed. These these are the test cases. This here requests for a prior. It calls the get location temperature for prior, and it outputs what it got from the server. This here calls the list supported cities resource, and it outputs what it receives from the server, while this uh, calls the create travel brief prompt server and outputs what it got. This it tests some of the callback handlers. It calls the get secure city stats tool. If you remember, that tool, like I explained, was essentially created to help test some of the callbacks. And so making this call is essentially trying to see how to the logs that are captured on the clients, um, um, demonstrating that those different callbacks are being called, are executing successfully. So at this point, we're going to try and run um, this. Okay. Now, connected to initialize to where the operations that I did before, initialize first, before initializing the clients. Here, print connected, the client connected, print initialized, the client initialized. So here, the client is connected. Why am I getting an error? All connection attempts failed. Why? Just a moment. Let me be sure that my server is actually running. Okay, I think my server is running on 8080. Did I use 8080 here? Just a moment. Okay, just a moment. It's a configuration. Just a moment. Let me start this server. Oh, So, again. Okay, now it's running successfully. Okay, so these are the logs from the client. And then I want to identify the captured logs. Yeah, here's one. Captured requested routes from clients. I think there should be other ones up there. So the client is able to capture logs from the server. And now at this point here we are at, okay, this was for the tools this changed notification here. And here we have the elicitation request running. Server requests, please enter. So we are supposed to enter the server access code. Assuming I just press enter without putting anything. Yep. It says error during editation. Passcode is required. So essentially the client is not providing it passcode, and this is what we expected, right? And the response here is telling us operation aborted by the user, just as expected from the server. Now I'll run again and enter a wrong what do you call it? A wrong server access key. It still tells us incorrect access code, just as defined in the server. And in the third one, I'll run it with the correct access key. I think that was MCP 2026. Just a moment, let's verify. Yeah, MCP 2026. Hold on. Just a minute. I should be run this. Okay. CP 2026. And that should now, because I provided the correct access code, it's giving the progress updates. So that's run correctly. And then the output success, and here shows us that it actually ran and got the stats for the given city, even though this is a dummy response. Any questions so far before we check the demo running on it, using this same client or as close to it as possible using the Langchain MCP adapter? Okay, and if I may ask, or was anyone able to set this up on their own machine so they can run it themselves? Who was able to do that? Okay, David, have you
Yeah.
tried running? Okay, have you tried running it yourself? But
Uh,
you need to run the server and the client on separate terminals if you want to use streamable HTTP transport.
exactly. I guess I was having that issue because I already have the MCP server and MCP clients in my VS Code, but then again, I was wondering, on how to run it, so I guess this just like give me an example of how I should basically run the code. But then again, I have question. This access code that you imputed here, is it hard coded in the code? Like, how do you get
It's
this?
hard coded. This is just the the idea isn't about access code. The access code is not the idea here. The idea is to demonstrate an elicitation request.
Yeah.
So that's the idea. I mean, typically you wouldn't this is nonsense authentication, right?
Mm,
The idea is to demonstrate elicitation requests where the server asks for some information from the client. It's hard coded.
mm,
See where I say if passcode, that's what it received from the client when it made the
yeah. Okay, if
external
passcode
request.
is that.
If
Okay.
it's not this, it does it. That means once it passes this block, it means it's this. So it's hard coded. That's
Mm,
not a good auth implementation. The idea simply is to demonstrate an elicitation request.
okay.
So it could have been something as simply, how do you greet in French? What is good morning in Spanish? And the response could be anything, but the idea is to demonstrate an elicitation request where the server asks for additional information from the user to enable it and complete processing the earlier request it received from the client.
Okay.
Any other question?
No, sir.
Okay, so we'll now look at implementing this same client using the LangChain MCP adapter. Now, here I've used the multi-server MCP client, which abstracts, yeah, that was the term I was looking for when I was trying to explain how the fast MCP framework differs from the MCP and Python SDK. It's abstract. So multi-server MCP client abstracts the connection, right? It allows you to, it allows your agents, your LangChain or LangGraph agents, to be able to connect to multiple MCP servers at the same time. So when you make a request from your host, as when you use the multi-server MCP client, it's going to determine automatically which exact server should this request go to, and automatically it will establish a connection to that server and forward that request. When a request comes from any of those servers, it will receive them. So it's like a client to multi-server implementation. Now, we had, when we use fast MCP to build a client, we had multiple callbacks. We had elicitation callback, we had progress handler, we had elicitation progress, we had log handler, we had notification handler, we had root callback, sampling, and so on. But in LangChain, when you use the multi-server MCP client, you don't have that number of handlers. So the only handlers that are available are for elicitation, progress, and log. For notification and routes, you make use of protocol and sampling. You make use of protocol integrations for that. And there's also another feature that LangChain provides. I'm trying to think to remember the name, but essentially it allows you to intercept. It provides. Just a moment. Just a moment. Let me try to. Okay, I'll remember and I'll send it to you on the Discord channel. So those are two things: the link to the MCP specification, and then this other feature I'm talking about. It has just escaped me. So essentially, we defined the same logic that we had for the elicitation handler, essentially the same logic that we had in the fast MCP clients. Similarly, for the log handler and for the progress handler. Now, for a notification handler, it doesn't use a callback. It uses a protocol integration. Essentially, when the server forwards a notification, this just intercepts it, and because it's a JSON RPC message, or the protocol integration already provides for intercepting that, and this logic gets executed. We'll test it and see how it works. When we look at the initialization of the clients, instantiation and initialization, you see here, you have to define, you have to define an object for the client, for the server rather. If you have multiple servers, you provide for all the servers. Remember that a multi-server MCP client allows you to connect to multiple servers. And now I'm only able to pass these three callbacks here. Meanwhile, with fast MCP, you could pass up to 6, if not 7, and that's, I think there are 6. Anyway, back here. For routes, really what you do, this is a routes update handler. What it does is, if you want to update your routes, right? Now, what this does is just to set the routes property of the session. So here you first get the MCP clients, the session of your MCP client, which is the multi-server MCP client, for a specific server name. Remember, routes is you're specifying routes for a given server. So the session of that the client's connection to a specific server, that means you need to provide the server name. And then you set the routes property. Once you've updated the value of the routes property, once the server makes a routes request, they will get whatever you set as the routes property. Compared to with fast MCP client, the client will build with fast MCP, where you have a callback that when the client makes a routes request, you can dynamically compute whatever you are responding with. And then for sampling, it's still similar. You receive the sampling request, you implement logic to surface that to the user to get their approval, and where the approval is given, you make an a call to the LLM, and then you also surface that to the user to approve, and if the user approves, you forward that to the server. So that's essentially, that's why initially when I talked about the client implemented with LangChain MCP integration, I said the same client, or at least something close to it. It's not exactly it, but it provides essentially those same features that we had in the client that we implemented using fast MCP. I think I've already shown here where the client is initialized. It's essentially the same logic where you can either decide to, well, I have a, this is where you specify whether you want to use simple HTTP transport or standard IO transport. So if you set this to false, then this client will expect that the server is using standard IO transport. If you set this true, it expects that the client, the server is using streamable HTTP transport. Well, this is set to true because my server is using streamable HTTP. Yeah, and I need to update the port number because I started the server it's specified that you run on port 8080. Yeah. Now, assuming you were using local standard IO transport, you need to specify that here, and then you need to specify the path to the server script. And of course, you won't have these headers here for you to be able to instantiate the server. So here you instantiate the server by providing this dictionary, as well as you attach whatever callbacks that you have defined. And so I also have a client, initialized client, but in this case, you must instantiate the clients. I mean, the client instantiates automatically when it's initialized, unlike in our fast MCP clients where we could specify that it should not auto-initialize. With the LangChain's multi-server MCP clients, you cannot specify that. The client gets initialized as you instantiate it. So I just did this for compatibility with what we had in the fast MCP client, and also trying to have that list of all the resources and all the tools. Unfortunately, the LangChain's adapter does not allow you to list all the available prompts. So it only allows you to do that for resources and tools. And I think somebody had actually, in the repo, somebody had actually, I think, requested that feature, but they said they are not trying to make this a replacement for the SDK, but they are just trying to provide, make it easy to use the most commonly used features so that it becomes easier to build agents using MCP. So you essentially can do that from within the LangChain framework without having to use external libraries. And so this is the same, well, or as close as possible to the call to function that we defined in the fast MCP client. This is also the get prompt. We don't really have, as in the functionality here is limited, like I mentioned. So it doesn't have like just how, what do you call it, like a get resource. It doesn't implement a get resource method, multi-server MCP clients. So you can only do get resources, and from that you get extract the data for the given resource that you're interested in. It doesn't provide a read resource, rather a read resource method. It doesn't. And so this is just the execution similar to what we had for the fast MCP client. But in this case, I think we're just Gabora as local. So I'll execute this. And note that we didn't call that tool the tool that handle the elicitation. I think there was what's the name of that tool? Yeah, get security stats. We didn't call it here. And so I would like you to, in your own, when you're running it yourself, try to call that tool and see whether which of the functionalities that we implemented there you're able to get from this client that's built with LangChain adapter for MCP. And I would like us to have a discussion. Probably I'll create a discussion thread on Discord for discussion on your experiences running these yourself. So we compare running with the fast MCP client, running with the LangChain MCP client. Any question? That's essentially what we have for today. So if there's no question, then we should just call it. Okay, David, go ahead.
Okay, so I want to understand it better, right? And so the last one, which is the LangChain MCP client that we just demoed right now, that means if I'm to work with the LangChain MCP client, that means I do not need the other fast MCP
No,
clients that we demoed.
those are just two different approaches that you can use in building an MCP client. You can use fast MCP clients, or you can use the multi-server MCP clients of LangChain.
Okay.
But know that the LangChain's adapter is limited. It doesn't provide all the functionality that you could get from the fast MCP client. Is essentially a wrapper around the MCP SDK, MCP Python SDK. So it provides essentially all the features that the SDK provides. For LangChain's multi-server MCP client is an abstraction, but it doesn't provide all the features. Just provide the most essential or most commonly used features to make it easy to build LangChain agents that make use of MCP. You can also
Okay.
check the Git repo to see exactly what it provides. It doesn't provide all the features that are defined in the MCP specification for clients.
All right. Thank you very much, sir.
Does any other person have any question? So if there's no question, that's fine. We'll call it a night. Remember that your stage 2 task has been uploaded to the LMS. And like I mentioned, it goes beyond what we had the stage 1 task. And likely as we continue progressing, the tasks will be getting more and more complex. So please try and work on it and ensure that you follow the instructions and preferably you submit before the deadline. Give a bit more time for this one. I think the deadline is next Wednesday compared to stage 1 task where the deadline was either the next Sunday. So deadline for this, I think, is next Wednesday. So try and complete it before then, submit before then. All right. Good night, everyone. As soon as we stop the class, I'll post the 2 things that I promised. Okay, let's trade now. I said I was going to create a thread so we can discuss your experiences running the code for both clients, the fast MCP one and the LangChain one. Those you want to say something?
No.
Okay. All right, then. So I'll stop recording now. Good night, everyone.
Yeah.
Good night, sir.
Sir.